Now we're going to talk about something called explicit formula, or an explicit formula, and how we can use this thing called an explicit formula to generate the 6 numbers in a sequence, the first 6 numbers, or any 6 numbers. So it doesn't have to be first, any 6 numbers in a sequence. Okay, so let's just start by defining it. An explicit formula helps you find any term in a sequence, and what's nice about it is you don't need to know the previous terms. Remember in a recursive formula we had to know the first term, and then we had to know each other term to get to whatever term, the 6th term. Well, this one you don't. You can just jump right away to the 6th term. You don't even need to know it. So, or don't need to know the previous term is what I'm trying to say, but maybe not too well. So here's how we use this, okay? We're going to try to find the first 6 terms of this right here, this explicit formula. There it is. We got this explicit formula. We got t sub n is equal to negative 2n plus 3. And what's nice is to find any term, what we do is we just put the number or the term in. Like if it's the first term, we put a 1 into it. And if it's the second term, we put a 2 into this, and we'll figure out the value for that second term. And if it's the third term, we put that in for the n, we'll figure out the value for the third term, so forth and so on. So let's just give that a shot. This shouldn't be too bad, right? Okay, so let's start off with the first term. We're going to plug that into this n right here. So we got negative 2 times 1 plus 3. Negative 2 times 1 is negative 2 plus 3, which is equal to negative 1. So our first term is negative 1. Okay. Now get your erasers, erase this all up, and let's find the second term. We're going to plug that in for our n right here. So we have negative 2 times 2 plus 3. Negative 2 times 2 is negative 4 plus 3. Negative 4 plus 3 is equal to, did I do something wrong on the first one? I feel like I did. Negative 1. Negative 1 again. What did I do wrong on the first one? Where did Mr. Benson screw up on the first one? It was, what did we plug in here? First one we put in a 1, a negative, oh, it should have been a positive 1, because this would be negative 2, negative 2 plus 3, okay, I'm sorry, everyone, that should be positive 1. Okay? And let's do the next term. We got, we're going to put a 3 in there, so negative, or we're going to put a positive 3 in there, so negative 2 times 3 plus 3, when we take this in there, put it in there, negative 2 times 3 is negative 6 plus 3, which is equal to negative 3. Make sure I did it right that time. Hey, do you guys notice the pattern here? We got positive 1 to this one to this one. What's the pattern? What's going on? Looks like this one's going down by 2, minus 2. This one's going down by 2. Well, let's see if this one goes down by 2, and if it does, I'm guessing that's the pattern. We can just figure out the next few from that. So let's put 4 in. So we got negative 2 times 4 plus 3, that's negative 8 plus 3, which is equal to negative 5. Negative 5 there. Oh, and it's going down by 2 again, yeah. So it looks like we found a pattern here. Looks like this, negative 2, kind of tells you what it's going up or down by 2 each time. So if it's negative 5, then we got negative 7 for the next one, because that would be subtracting 2. And let's subtract 2 again and get negative 9. And those are the first 6 terms of a sequence, and we generated those using an explicit formula, and actually we found the pattern for it and just filled it all in. In the next section, I'm going to show you how I can find the sum of a series given a summation, or this thing called summation, not summation. Summation notation is right here. We'll talk about that in the next video.